solving methods now. We've done factoring, which is really nice. If something factors, factoring is a really nice way to get the answers. Graphing. Graphing is helpful, but if it's not rational, it just gives you really weird decimals that aren't helpful. And then we've learned quadratic formula and then a new method today. So if you don't factor, we're going to fill in the blanks here. The first method you could try is using your quadratic formula, which you should know, hopefully, from all the times you've done the quadratic formula. It always works. It's just kind of time-consuming sometimes to calculate things. There's a lot of calculator stuff involved. Whereas this new method we're going to learn, complete the square, is just more streamlined. But both of them have pluses or minuses, which we'll really talk about more next week. I'll kind of introduce the minus of one of them today, but generally they're both very helpful. So some vocab that's going to help us as we go through the lesson today. 25 is a special kind of number, and we've been talking about these numbers the last couple days. Oops, that's not the right letter. It's a perfect square. Yep. I was writing the second letter first. So we all know what a perfect square is. It's a number times itself that gets me an answer. Okay, we've done that with numbers. Now, we can actually extend that concept into polynomials. So we have x squared plus 6x plus 9 is what we call a perfect square trinomial. Now, what's a trinomial again? A polynomial with 3 terms. Now, why do we call it a perfect square trinomial? Well, if you notice here, when I factor that trinomial, I have x plus 3 times x plus 3. It's the same thing times itself, which is exactly what a perfect square number is. Now, how is this going to help us? Well, when I look at this 5 times 5, would you agree that you can write that as 5 squared equals 25? Yes, okay, no argument there. How could I rewrite x plus 3 times x plus 3? X plus 3, the quantity squared. Now that might not really mean anything to you right now, but that right there is what's going to help us do this method of complete the square. Our goal in complete the square is to create an equation. So we are going to manipulate the numbers so that we get a perfect square trinomial that factors like this. Right? We can do that. We can make it into what we want so we can get our answer. So let's see how it goes. The next part here, the first problem, it says we'll do complete the square and quadratic formula. We'll probably just do complete the square. But there are some steps written there for you. Now, the first step says divide all the terms by the coefficient of x squared, if it's not 1. Well, in this first example, we have a 1 there. So in order to do complete the square, you have to have a 1 in front of the whole thing. So I can skip step 1 because I have that coefficient. Step 2 says rewrite the equation as x squared plus bx equals c. What does that mean to do? Yeah, minus the 3 to the right-hand side. So you want to move the constant over to the right. Now, when you do this, I'm going to ask you to add something in here. You'll do 8x squared plus 8x. Now, in place of the 3, I want you to put a box plus a box, or plus a square, because we're going to be completing the square. I want to put a placeholder there, because I'm going to fill in that box. And then on this right side, I'll have negative 3. Now, if I put a plus box on the left, to balance the equation, I have to put plus a box on the right. Right? So what we're going to do is we're going to fill in that box with a number. So if I add something to the left, I have to add it to the right. Good with me so far? So make sure the leading coefficient is 1. Subtract the constant per box on both sides. Now we have to fill in the box. And to fill in the box is step 3. It says add b over 2 squared in each box. So which number would be the b up here? 8. So you're going to take 8 divided by 2 and square it. Well, what's 8 divided by 2? 4, and 4 squared is 16. 16 goes in your boxes. All right, now, it says factor the trinomial. Well, before we do that, let's simplify the right-hand side. Negative 3 plus 16 is 13. Now, we're going to factor it. I'm going to do this in a long step, like 2 times, and then we'll shortcut it from here on out. What 2 numbers multiply to 16 and add to 8. 4 and 4. So I have an x in both. I'll put a positive 4 in both of those. Now, first of all, that is what we called up above a perfect square trinomial, because both of the factors are the same. So how could I rewrite that left-hand side? X plus 4 squared. Okay, so this is always going to happen. Now, before we move on, do you have any idea there's a connection here between all these 4s? Where did the 4 come from? Where did you see 4 before?
A divided by some 8.
Yeah, the middle term divided by 2. That's always going to happen. So if you want to make a note to yourself, that 4, when you factor it, is always going to be half of b, half of the middle term, every time. Because what we did is we manipulated the problem so that that would happen. Okay? We were trying to force it into this. We did that. All right, we're almost there. Now all we have to do is solve for x. What would you do first to solve? Square root. Square root, square root. So you got x plus 4 equals. Now, because I have a square root here, this is where we don't just want the positive. We have to remember that there are 2 answers when you square root. A positive and a negative square root of 13. You have to put the plus or minus. Your last step is to get x by itself, is to subtract 4. Now, when I subtract 4, have we ever seen plus or minus radical 13 minus 4 written like that? Now, where does the negative 4 usually go? In front. You're going to squeeze it in front of the plus or minus. So you'll have x equals negative 4 plus or minus radical 13. And that's exactly how you could leave your answer. Now, would you say that's rational or irrational? Irrational. So think about your quiz today. If you had irrational roots, what kind of number would be the discriminant?
A non-perfect square.
Yeah, non-perfect square. So I'm not going to make you do the quadratic formula, but do you see how, once I'm not talking through this so much, how this could be faster and nicer? Yes, what's up, Maddie? Because when I take the square root of a number, like I take the square root of 36, for example, that could be technically positive 6 or negative 6, right? Because if I square either one of those, I get 36. Same thing, when I square root 13, it can either be positive square root of 13 or negative square root. All right, we good? All right, I'm not going to make us do the quadratic formula on that one, but you'll take my word for it that it gives you the same answer. Okay, let's go down to the next one. Number 2. So start the same way. Still, I look. Is there a number in front of x squared other than 1? No, so I can jump right into it. What was my next step? What does it say? Subtract the 30. So when I subtract the 30, what do I have to put in its place? A box. Okay, so rewrite this as x squared minus 10x plus a box equals negative 30 plus a box. Now, who remembers how I fill in the box? Half of the middle term squared. So you can do that in your head if you want, but I'll write it down here for us. What's half of the middle term? Negative 5, and then squared is 25. And when you square any number, it's always going to be positive. So make sure, bless you, that box always has a positive number in it. All right, the right-hand side, negative 30 plus 25 is negative 5. And then over here, you can shortcut this if you want. I'll do that in just a second. But how is this left-hand side going to factor? Negative 5 and negative 5. All right, remember, this b, this number right here, take that b divided by 2, and that's the number that goes in both parentheses. Well, how can I shortcut that if I don't want to write all these steps? What is that automatically going to become? X minus 5 squared. If you look at my key, I jump to that step every time. You're welcome to do that. I don't need to see both x minus 5s if you know it's going to turn into that. Okay, because it's always going to. Are we good so far? All right, let's square root. Square root, square root. let's see, we will have x minus 5 equals, what do I have to write first? Plus or minus the square root of negative 5. Can I simplify that square root? I radical 5. So we plus or minus I radical 5. Okay, all I have to do is add 5, and where does it go when I add it? In front of the plus or minus. So if x equals 5 plus or minus I radical 5. So those would have two imaginary answers, and from your quiz today, what kind of discriminant would give you two imaginary answers? And -1. Good. All right, we catching on okay? We'll do like 1.5 more. You'll see why the third one's just a half. Number 3. Ooh, that is not set equal to 0. What do you want to do first? Set it equal to 0. Okay, so let's move everything over. Let's subtract the 4x and add the 2 to that left-hand side. So 3x squared. When I subtract 4, I get minus 12x plus 6. Now, can I complete the square as that is? No, what do I have to do? Divide everything by this leading coefficient. I cannot do quadratic formula when I have a 3 out front. Complete the square. You can do quadratic formula. Sorry about that. All right, so when I divide, for now, for this unit, I don't need that 3 anymore. I can just divide and make it go away. When we come back from winter break, we're going to need that 3, but for now, we don't need it. All right, what's the next step? Minus the 2. Okay, so I'll have x squared minus 4x plus my box is -2 plus the box. I was going to go in both boxes here. 4. How'd you get 4? Yeah, -2 squared is 4. Okay. So my right-hand side, -2 plus 4 is 2. What is the left-hand side going to factor and condense into? X minus 2 squared. Is anyone not sure how I got x minus 2 squared? My suggestion, this is, because if I factor it, it's x minus 2, x minus 2. Now, the reason I like to skip right to this step is because if you write out every step, which you're welcome to, but it doesn't make this process faster. If I, know that it's always going to jump to this, if I recognize the pattern, that's what makes complete the square so fast. All you have to do is square root. You get x minus 2 equals, what do I have to put in front of the plus or minus? Sorry, it's a Friday. What do I put in front of the square root? A plus or minus. And then I add 2. So what's my final answer here? X equals, 2 plus or minus radical 2. All right, like half of this one will do. Flip your page, last one. 3x squared plus 5x plus 6. Can I do quadratic formula? Complete the square as it is. No, what do I have to do? Divide by 3. Okay. So I divide by 3, and I get x squared plus, 5/3 x plus 2. Are we already sweating because we see a fraction? Yes. Okay, what do you have to do next? Minus the 2. All right, stay with me, guys. We're okay. We got x squared plus 5/3 x plus a box is -2 plus a box. All right. So let's think about what's going to go in that box here. We would take half of this middle number, so I'd take 5/3 divided by 2 and square it. What is it? 5/6 squared, which is 25/36. Uh-oh. Does this look like one that we really want to use complete square on? No, I mean, we could. We're kind of almost there. I'm not going to make us finish this one. But why do you think complete the square is probably not our best option for this problem? Those are ugly numbers. Why do you think we got an ugly number on this one but not the other ones? Where did the ugly number, like what part? It came in the B here, right? Let's look at B really quick. B, see it's a 5 here.
B is odd.
B over here, oh, it doesn't have to be a perfect square, but B over here is 4. B here is negative 10. B here is 8. What do you notice about all these B's? 8. They're all even. And this problem, the B is odd. So it turns out this is the one downside to complete the square. If your B is odd, it's complete the square works, but you're going to have to deal with a lot of fractions along the way. Complete the square works best when your middle term is even. And we'll talk about that more next week because eventually you're going to be given a problem and I'm not going to tell you what the best method to use is and you're going to have to figure that out. But we'll explore that later. But does that make sense? Cool. That's what I have for you. There are 4 problems on the back. We're not going to do the quadratic formula. Trust me, quadratic formula will be faster. So 4 problems. Answers are down there. Make sure